This podcast is going to go through redox reactions, some basic overviews, and then how to write half reactions or net ionic equations. Just as a friendly reminder, when we're talking about redox reactions, we're actually talking about oxidation and reduction reactions. And as a friendly reminder, oxidation reactions are where we lose electrons, and reduction reactions are where we gain electrons. So let's start with this first example. Here we see sodium with a charge. It's got a +1 charge, and we see that 1 electron is added to that. So it is gaining 1 electron. And then the tricky part about seeing a compound by itself is knowing that when it's by itself and you don't have a charge there, that it is a neutral element. So here, our sodium has gained an electron, so therefore our sodium was reduced. Looking at our next example, we start with nickel, and remember, if we don't see a charge and it's not bonded with anything, we assume that that nickel has a neutral charge or no charge at all. And on our product side, we notice that we now have nickel that has a charge, and we have 2 electrons. So one way to think about this is that those 2 electrons have separated from your nickel. So therefore, the nickel that had an equal amount of protons and electrons in the beginning in our reactant side lost 2 electrons. So therefore, our nickel has been oxidized. All right, in our last example for this page, we have chromium with a 3+ charge. Chromium has already given up 3 electrons. We notice that here we're adding 3 electrons to it. So we have a -3 charge and a +3 charge, and therefore we're going to wind up with chromium, which has no charge. So here we can actually see in the beginning of the equation that we are adding electrons. We're gaining electrons, so therefore chromium is reduced. Now that you get the general idea of identifying if we are losing or gaining electrons, let's take a look at a full equation where you have, in this first example, we're going to have to write the half reaction for each species, and we'll figure out who is oxidized and who's reduced. So to write a half reaction, you want to separate out your elements. So let's start with lead. I have in this equation 2 lead, and it's important to note that this lead is in an ionic compound. Because it's in an ionic compound, we know that electrons have already been transferred, and we know that in this case, since it's 1 lead and 1 oxygen, which has a -2 charge, that this is a +2 lead that we're speaking about that's in this reaction. So we know in order for these two, this metal and the nonmetal, to come together, there has to be a transfer of electrons. We know that 2 electrons were transferred from lead to oxygen. So as it stands, if we were to separate out this lead, we know that it has a +2 charge. Okay, and looking at our product side, we have 2 lead, and the lead is standing alone, so we would assume that it has no charge at all. So how did we get from 2 lead with a +2 charge to 2 lead with a neutral charge? We had to add electrons. So we need to add electrons to our reactant side. Let's go ahead and erase this and give ourselves some more room. So we're going to add electrons here. Now you have to think about how many electrons do we add. Well, I have 2 lead that each have given up 2 electrons. So altogether, there was a transfer of 4 electrons. So I will add or gain 4 electrons to those 2 lead to get a neutral charge. We can also look, okay, I have 2 times the +2 charge is a +4 charge, and I'm going to add to that a -4 charge with my electrons. I will wind up with a neutral species. Looking at oxygen, we have 2 oxygen in our reactant side. Remember, this 2 applies to everything. And oxygen in this particular compound has a -2 charge. In the product side, oxygen stands by itself. We have 2 oxygen. I'm going to write it just to emphasize that we have 2. It is a neutral compound. So the question becomes, where did the electrons go? Are we gaining them or are we losing those? And in this case, we have a -4 charge for our oxygen, and it goes to neutral. Well, in order to do that, we're going to have to lose 4 electrons. So I will add my electrons to this side, showing that those 4 electrons separated out. Okay, so looking back, we can see that our lead has gained electrons. It is reduced. And our oxygen has lost electrons. They've split apart as a result of the reaction. We had the electrons here. We do not have them afterwards. They're separate. So this has been oxidized. All right, let's try another equation. We're looking at chlorine being added to sodium bromide to form sodium chloride and bromine gas. So let's start with chlorine. Chlorine here is neutral. We have 2 chlorine molecules are diatomic. There's no transfer of electrons. And on our product side, I noticed that chlorine has been, electrons have been transferred to chlorine. It's in an ionic bond. And one way to think about this is to think about the Lewis dot structure. So chlorine has 7 valence electrons. To become part of this ionic bond, we'll see a transfer of 1 electron from sodium to chlorine. So now we have a +1 and a -1 charge that's holding those 2 elements together. So according to our coefficient, we have 2 of those chlorines, because remember the coefficient applies to both, and each of those single chlorines has a -1 charge. In order to go from a neutral compound on our reactant side to a charged species, we're going to have to gain 2 electrons because this overall charge is a -2. So to the reactant side, I'm going to add 2 electrons. So that's like saying I have no charge, and I'm going to add a -2 charge. That gives me this -2 charge that I'm seeing on chlorine. All right, let's look at our next element, and let's skip to bromine for this example. So my coefficient tells me that I have 2 bromines, and my bromine is in an ionic bond with sodium. Okay, so again, I'm going to think about this in terms of valence electrons. I know bromine has 7 valence electrons, and that there was a transfer of electrons from sodium to bromine. So that bromine has a -1 charge. I have 2 of them, so I have an overall -2 charge. On the product side, bromine is bonded with itself. It has a neutral charge. So how did I get from a -2 charge to no charge? I would have to lose 2 electrons. So to my product side, I'm going to write the addition of 2 electrons. So what this is showing me is it's showing me that I have lost 2 electrons from my initial element. So my element had 2 extra electrons. Those were lost, forming a neutral bromine, and those 2 electrons are no longer part of it. Looking at our last elements, let's look at sodium. We have 2 sodiums, again, bound up in an ionic bond, so it has a charge. Each one has a charge of +1, and we have 2 of those. So our overall charge is +2. On the product side, it is also bound up in an ionic bond. There was a transfer of electrons, so my 2 sodiums also have a +1 charge. In this situation, when you're trying to figure out what the heck's going on, I don't have a change in either of these charges. I go from a +2 charge to a +2 charge. There's no change whatsoever, which tells me that there was no gain or loss of electrons. So we call this a spectator ion, not really part of the reaction. So going back to chlorine and bromine, we have to figure out who was oxidized and who was reduced. So to find out who was reduced, we need to see who gained electrons, and that is chlorine. Chlorine gained 2 electrons to get this ion. So chlorine was reduced, and bromine lost 2 electrons. Bromine was oxidized. This this is more indicative of the type of problem you would see on a quiz or a test where we don't give you the entire balanced equation, we make you work for it. So the first step of this would be to write out our reactants and make sure that we have neutral compounds using our subscripts. So we have aluminum metal, which is by itself, so no subscript. We don't have to worry about charges. And that is being added to iron, which according to our Roman numeral has a +3 charge, and oxygen, which I know looking at my periodic table has a -2 charge. So determining my subscript, my 2 comes down and my 3 comes down. I'm going to rewrite this so it looks cleaner. I have Fe2O3 and react is an arrow. So now I need to ask myself, what type of reaction is this? Well, I have a single element and a compound. That is most likely a single replacement reaction. And in a single placement reaction, I know that my cations are going to swap places. So I need to predict the products based on my classification. So now I know that iron's going to be all by himself and that aluminum is going to be in an ionic bond with oxygen. Well, I can't take my subscript that I had previously because that was based on charges, so I have to find my charges and determine my new subscript. So my subscript will be Al2O3, and I'm going to erase my charges. So now that I know what my products are, and I've predicted my products as well as figured out my neutral compounds, I am going to then have to balance. So I have 1 aluminum on my reactant side and 2 on my product side. So I'll put a 2 in the coefficient spot for aluminum, and that is now balanced. I have 2 irons on the reactant side, and I have 1 iron on my product side, so I'm going to put a 2 in the coefficient, and those are now balanced. 3 oxygens on the reactant side, 3 oxygens on the product side. We're good. We don't have to change anything. So now my next step is to write half reactions for this, so I can figure out who's gaining electrons and who's losing electrons. So let's start with aluminum. I have 2 aluminums, and they have no charge because they're not bound. There is no transfer of electrons, no ionic compound. On my product side, my aluminum, and I have 2 of those, I'm going to write that as a coefficient, is in an ionic compound. And I know that those 2 aluminums each transferred 3 electrons to my oxygen. So I know that they have a +3 charge now. So we had a transfer of electrons. I started out with a neutral compound, and then I've lost a certain amount of electrons on my product side. So looking at this, each aluminum, and I have 2 aluminums, lost 3 electrons. So my total electrons lost is 6 electrons, and I'm choosing to put it on the product side because this accounts for all of my charges. So I have a +6 charge here and a -6 charge here. That accounts for my aluminum not having a charge. All right, next let's talk about iron. Iron has a +3 charge. I have 2 irons that have lost 3 electrons each, or lost a total of 6 electrons. And on my product side, I now have 2 iron that are neutral. They have no charge. Well, how did we get no charge? We had to add a certain number of electrons to the reactant side in order to become neutral. Well, my charge of this species right here is a +6. So in order to become neutral, I have to add 6 electrons to the reactant side to get that product. Finally, let's talk about oxygen. We have 3 oxygens on our reactant side. Each have a 2- charge. So that means I have 3 different oxygens that each took on 2 electrons apiece. On the product side, my oxygen is bound up again, and I have 3 oxygens, again with a 2- charge. Notice that there is no change to my charges. There's been no change to that oxygen, so I'm going to classify this guy as a spectator ion, and he is not involved in the transfer of electrons. So let's go back to aluminum and iron. Aluminum started out neutral and then lost electrons. to come up with a positive 3 charge. Because they lost electrons, we can consider aluminum to be oxidized. Iron gained electrons to become neutral. Because it gained electrons, iron was reduced.